Alright, so this is a really good photo that can show where we would expect to find different sizes of sediment and therefore different types of sedimentary rocks. This is a delta. It's probably the Mississippi River, even though I'm not sure. But you can see that we have a river that is starting out on the land, which is down the bottom of the figure, and then it goes to the edge of the land, to the shore of the ocean, and a nice large delta is present where the rivers have been dumping their sediment. And then out in the ocean area, you can see that there is still sediment that is in the water column where you can see some very light colors, and that sediment is being moved by very shallow ocean currents, very weak ocean currents. So if we had to guess what type of sediments we would find at various locations, we should be able to predict it based on what we've now learned about sediment size and energy. If we look at A, which is down at the bottom of the figure, you see that it's well within the continent area and where we have a true river channel. So that channel is moving water at a fairly high energy, especially when you compare it to the energy at the delta and at the ocean boundary. So we would expect to find the largest grain size with the highest amounts of energy at location A. As you move from location A out to location B, we would expect a drop in grain size. Similar to you taking your thumb off of the hose, the amount of energy that is in water once it comes out of the mouth of a river is vastly decreased almost immediately. So the material that this delta is made of is going to be much smaller in grain size because it takes less energy to move it along than it does the material at location A. Also, if we move further out towards the ocean and actually get into the ocean beyond where the delta is petering out, we get into very low energy. And that low energy can only hold up a very small size of sediment, a clay or a silt. So this material that's now out in the ocean, that's drifting with the ocean current, we can assume to be very small. So as this sediment then is lithified and turns into rock, we can have any type of environment come over these previous environments. But the energy and therefore the type of environment are preserved in the rock record. So by looking at the type of sedimentary rock, we can then deduce what the actual physical environment was before we had the rock lithified. This is helpful when we're trying to decide if shorelines have shifted and various other environmental factors.